Welcome back to Math 109 Plane Trigonometry. In this video, we're going to take a look at the inverse trigonometric function definitions for the various trig functions. So we'll start by taking a look at the sine function. So there's roughly what the graph of the sine function looks like. And if we'll recall, at negative pi over 2, that function hits a valley. Likewise, at pi over 2, function hits a peak. In between there, we don't repeat any y values, so on that interval, it is a one-to-one function. So that interval is the closed interval, negative pi over 2 to pi over 2. So we're going to use that interval to define this function for the purposes of inverting it. So we can say y equals the inverse sine of x. Be careful that negative 1 there is not an exponent. It's indicating undoing the function, or inverse function. You will also occasionally see that written as arcsine of x. But either way that that's written, that's going to mean that x is equal to the sine of y, where we're restricting y to be between negative pi over 2 and pi over 2. Oops. So that's how we define the inverse sine function. For the cosine, again, we're going to take a look at the graph. And I did not quite draw that well. That function is supposed to peak at the x-axis. And then it reaches that valley at pi. In between there, we don't have any y values, and we wouldn't if I had drawn this correctly. So we can restrict our domain here to the interval 0 to pi. So that will allow us to define the inverse cosine function. And again, this could be written as arc cosine. I'm not going to bother doing it this time. But that would imply that x is equal to the cosine of y, where this time we're restricting y to be between 0 and pi. Then the final one we're going to take a look at is, actually we're going to look at both tangent and cotangent together. First, the graph of tangent, and then I'll go ahead and put the graph of cotangent in here. So in this case, we're going to take a look at where those asymptotes are. For tangent, those are at negative pi over 2 and pi over 2. For cotangent, we have 0 and pi. And we're always going to define our intervals so that those first positive angles are going to be in the interval we're interested in. So for tangent, we're going to restrict the domain. This time we're going to use open parentheses to indicate the interval. Negative pi over 2 to pi over 2. We're using open parentheses here because we have the asymptotes here. The tangent function is not defined at x equals negative pi over 2, so we don't want to include it in the restricted domain. And similarly for cotangent, because of where the asymptotes fall, we're going to let our interval be 0 to pi. Again, not inclusive. So from this, just like we did with sine and cosine, we can define y equals the inverse tangent of x. And again, we could use arctangent here. That's going to imply x is equal to the tangent of y, and negative pi over 2 is less than y is less than pi over 2. Similarly, y equals inverse cotangent of x implies x is equal to the cotangent of y, where 0 is less than y is less than pi. And we can also derive definitions for the inverse secant and cosecant, but basically when working with that, we're going to work with the inverse or reciprocals of them and work just straight from cosine and sine. So that's the definitions of the inverse trigonometric functions. In the next video, we're going to take a look at ways that we can turn some compound trigonometric functions into algebraic functions.